Welcome to Chemistry Hoff. My name is Mrs. Hoff. In today's video, we're going to be looking at accuracy and precision. I'm going to describe what accuracy and precision are. We're going to look at several mathematical tools that can be used to calculate accuracy and precision. And then we're going to be looking at some data, and we're going to identify data sets that are accurate and precise. Hope you enjoy this video. It's important to remember that when we are in a chemistry lab and we are making measurements, that we need to make sure that our measurements are both accurate and precise. In everyday language, these are often used synonymously or they're used interchangeably. But in the world of chemistry, these actually have two different meanings. We could also calculate this using two different equations. Let's go ahead and take a look at each term individually, and then let's look at some data to understand what these terms actually mean. When a measurement is said to be accurate, it means that it is close to the true value. So, for example, let's say that you measure out a sample of water. You use a graduated cylinder, and you read that the measurement to be 12.5 milliliters. We sometimes might call this the experimental value, because it is the value that you are getting when you are doing an experiment. But the actual, or sometimes called the true value, in this case is 12.4 milliliters. We see that there is a slight difference between the measurement that we took and the actual or the true or accepted value of the volume of water. Now, we could actually calculate how far we are off. And we use this using what's called our percent error. Our percent error is going to be our experimental minus the actual divided by the actual times 100. Notice that on this equation, we have these hard lines. These mean that this is going to be an absolute value. So whatever you get, your experimental minus actual, you're going to always take the positive value of that. Now, you want your percent error to be close to 0. The closer to 0 it is, this means that it is more accurate. So let's see what our value is with the data that we have at the top of the screen. All right, so if we use our equation, we have our percent error is going to be equal to 12.5 milliliters minus 12.4 milliliters divided by 12.4 milliliters. And then we're going to multiply that all by 100. In this case, I get 0.806%. We see that my percentage is very close to 0, so this means that my experimental value was fairly accurate. When a measurement is precise, it means that when measured multiple times, those measurements are close to each other. So let's say, for example, that you measure the volume of that water. You have 12.5 milliliters. You have 12.3 milliliters. And maybe you have 12.1 milliliter. How close each one of these measurements are to each other is called precision. So we can see that these measurements are fairly close to each other. And we could actually calculate this value by doing a calculation called average deviation. Now, in order to calculate our average deviation, the first thing that we're going to have to do is we're going to find the average of these values right here. So I'm going to take 12.5 plus 12.3 plus 12.1, and I'm going to divide it all by 3 to get the average value. We get our average value to be 12.3 milliliters. Now what we're going to do is we're going to figure out how much each one of these values deviates from the average, which is where we get the word average deviation. So in order to do this, I'm going to take the sum, that's a symbol for sum, of all of my values. So let's say I'm going to call these trials. So for example, trial 1 minus the average plus trial 2 minus the average plus trial 3 minus the average, and then divide all of those by 3. This is going to give me what's called my average deviation. And the smaller this number is, the more precise my values are, or the closer together they are. So let's go ahead and plug this in and solve. I get 0.133. Now, in order to represent this, what we do is we tack it on to the average and we go plus or minus 0.133. So we can actually add that on to our average, and this would be how we record our different data points and show how precise our measurements actually are. Let's go ahead and look at some more data and see what information we could derive from that. Okay. Here what we have is we have 3 trials, and we have 2 groups. Each group calculated the density of an object. We see that group 1 has 24.5 grams per milliliter, 30.2 grams per milliliter, and 33.4 grams per milliliter. Group 2 has 33.2 grams per milliliter, 33.8 grams per milliliter, and 33.3 grams per milliliter. Looking at these data sets, I can actually already tell something right off the bat. I can actually identify that if you look at group 2, my deviation between these groups is actually really small. So this right here is actually more precise, meaning that all of my measurements are closer together. Now let's figure out which one of our groups are actually more accurate. Now we do have our actual density, and so we're going to figure out which group is more accurate, and we're going to do that based off the average of each group. So let's go ahead and figure out what our average is for each group. Group number 1, 34.5. I'm going to leave off my units for now. And then we're going to divide this all by 3. All right, I get my average to be 32.7 grams per milliliter. Let's go ahead and figure out our percent error for group number 1. My percent error is going to be my average, or my experimental, minus the actual, all divided by my actual times 100. I get my percent error for this one to be 1.87%. Let's go ahead and do the same thing for group 2 and see what that value is. My average for this ends up being 33.4 grams per milliliter. Let's go ahead and figure out what our percent error is. My percent error for group number 2 ends up being 4.05%. As we can see, group 2 has a larger percent error. Because group 2 has a larger percent error, that means that group 1 is more accurate. So again, recapping what we saw in this example. We saw that group 2 was more precise, and that was because those values are closer together to each other. We could also use our average deviation equation to calculate the average deviation for each trial. However, again, looking at these values, it is fairly easy to see that these are together in group 2 than they are in group 1. When we compare these two groups and we actually look at their percent error, what we see is that group 1 is actually more accurate because its percent error is lower than group 2. What's on the screen is something that is often seen when talked about things that are accurate and precise. If we think of this as a bullseye and we think of each one of the black dots as being an arrow or a dart that is thrown, we can kind of get a good visualization for what accuracy and precision actually are. Notice that when precision is high, we have our different trials grouped together. So the grouping that is close is equal to high precision. It doesn't matter that some of those groupings are close to the center or some of those groupings are further off to the side, like in this one right here. The fact is that since they are grouped together closely, we say that those are very precise. Now, if you want to talk about accuracy, you need to look at how close they are to the center. So here what we have is we have low precision, but we see that this is close to center, which means that we have high accuracy. Of course, when we are doing an experiment in the lab, this is our goal. Our goal is always to have high precision and high accuracy. You achieve this in a lab by, first of all, being careful about what measurements you are actually reading. You want to make sure that you are using the right piece of equipment for the right job. When in doubt, use the smallest piece of equipment possible. When I mean that, I mean the difference between using like a 10 milliliter graduated cylinder and a 100 milliliter graduated cylinder. If you're doing something that only requires you to use a small graduated cylinder, use a small graduated cylinder. You also want to be careful about any transfers that you make throughout the lab. Small errors with transfers can definitely ruin your accuracy and your precision from trial to trial. Be sure to follow the directions carefully, follow each step, and make sure that you take your time and go slow. The biggest mistakes that I see in a lab are when students try to hurry up and get done with the lab instead of taking their time and really making sure that they are doing the lab correctly. Hope this video was helpful and that now you have a good idea about the difference between accuracy and precision.